Now we will study about the physical properties of S block elements. Now S block, as we know, are divided into two parts, that is group 1 and group 2. Hence we will study group 1 and group 2 both physical properties. But first we need to understand what physical properties is. Now properties is anything which define an element, right? For example, your name defines you, your height defines you, your weight defines you, that you are 50 kg or your height is 5'4", or your name is this or that. These are some properties that defines you. Similarly, an element properties also defines it. And what do we mean by physical properties is that physical properties are that which can be observed. Physical properties are that which can be observed or calculated or calculated. For example, you can calculate your weight, so it is a physical property without changing any combination, out changing its composition, right? That is what physical properties are. For example, let us take, it is used to as define an element. So anything that defines element is known as its physical property. For example, color, or you can say order, or texture of that element, or boiling point of that element. Anything which defines it is known as its physical property. Now there are many physical properties which are present in this time, where we can tell us about if that element is having an atomic size, or its order, or its density, or its boiling point. To understand that, first we need to understand every property separately. So we'll be first studying about atomic size. Atomic size or ionic size also. Atomic size and ionic size. Now, what are atomic size or ionic size? Now, atomic sizes, as we know that atomic size, let us take an example to make you understand. This is an atom, it is its nucleus, and it is the last boundary. So the distance from the nucleus to the last boundary is known as its radius. Radius. That is r. Now, if the radius of an atom is bigger, then its size is obviously bigger. And if a radius of an atom is small, then its size is also small. So atomic radius, that is radius from nucleus to the last boundary, is known as atomic radius of an atom, is used to define an atomic size of an element. That is, if I take, for example, lithium, and then I take an example of sodium. Lithium is smaller in size, but sodium is bigger in size because the distance from nucleus to the outer boundary and the distance from nucleus to the outer boundary of sodium is greater, R2 and R1. As it's clearly seen that R2 is greater than R1, hence the size of sodium is greater than that of lithium. So here radius is used as a measure to calculate the atomic size of an element.